So, good afternoon, everybody. My name is Marty Schoch, and today we're going to talk about going to the next level. And I'm going to be joined on stage here with Matt Ingenthron. He is Senior Director of Developer Experience.
Yeah, pretty much, yep. And also do some of the SDK engineering work with that team quite a bit.
Great. So I'm going to dive right in, and then we'll see Matt will jump in as we get later in the slides. So, lessons from Goat Couchbase.
Marty.
What?
There's a goat on your slide.
Oh, okay. Yeah, sorry about that.
Your auto animal insertion algorithm has kind of picked up a typo.
Yeah. Well, no.
Oh,
Okay,
that's better.
That's better.
Yeah.
Okay, we're good.
Thanks.
Lessons from Go at Couchbase. So it all started with a team we have called Couchbase Labs. I'm sure many of your organizations probably have similar teams. Generally a smaller team, and you're given basically no rules. You're told to go off, be creative, come back with something, surprise us. And that's a great opportunity if you get to be on such a team. As I said, it started with about 2 engineers. And we started looking at what we were going to build and what pieces we might need. And we said, well, what if we use Go? It has very easy concurrency, easy HTTP servers, HTTP clients, easy to work with JSON, a very rich standard library. So it sort of like met all the checkboxes we were looking for. So we started using it. And we really, as you can see by the timeline, started to like it because we've, over the years, built quite a bit of stuff at Couchbase using Go. I'm not going to go through the whole timeline, but you can see we started with an internal Couchbase SDK back in 2012, Sync Gateway, which is now out in production as a part of the mobile product. It was built with Go. And so some of these have made it out into production, and some of them haven't, right? That's kind of normal for a labs kind of thing. Sometimes you build something, you use it for a while, you kind of retire it. That happened with things like CBFS. As you can see, we've built up quite a lot of experience because over using this for so many years, we've learned a lot along the way, and that's really what we're going to highlight today. So I put out a little survey amongst our developers and asked, well, what do you like about Go? And there are some common answers here. So almost universally, everybody liked the tooling. The fact that it ships with a CPU and memory profiler that just work and give you exactly what you want out of the box, it's a huge win. There's a race detector, which is excellent for finding a whole class of concurrency bugs that, again, are very, if you don't have that, you just sort of take for granted that you're going to need such a thing. And then, of course, integrated unit tests. The unit tests are baked in, which really encourages developers to write tests from the very beginning. I didn't mention it here, but also it's very easy to do code coverage reports. So you get this sort of gamification process where developers are competing to sort of get their code coverage ranks up to 100% for a project. It sounds silly, but hey, if that's what it takes to get developers to write tests, that's great. A couple little more minutia things here. Channels can be used for synchronization as well as communication. So again, you tend, when you first use channels, you tend to think of them as something to communicate between Go routines, but sometimes you're just using them to coordinate between Go routines as well. And then the ability to satisfy an interface without importing its package. Again, that sounds like sort of a really minor, obscure thing, but in a lot of languages, when you want to satisfy an interface, you have to sort of import its name or its package and reference it. And in Go, you don't have to do that. And that actually is pretty liberating sometimes when you're rearranging your sort of separating your project out into more modules and avoiding those circular dependencies. That's a great feature to take advantage of. But it's not all great. What don't the developers like about Go? Well, one of the big things you hit right away is there's no good debugger. There is GDB with some additional scripts can do a decent job sometimes. But again, it works in certain cases and not others. There's a handful of others out there. There's one called Delve that we've started looking at initially in early stages. And there's another one called Go Debug. And these are maybe promising. And I've heard rumors that the Go team themselves are working on building additional tools as well. But right now, it's not a very good story. Another common complaint is that the way errors are handled in Go. So in Go, error is an interface, which is really powerful because it means an error could be as simple as just a string, or it could be a more complex structure, which maybe has numeric codes, error messages, and things like that, whatever your application needs to sort of propagate back. But all too often, it's just a string. And you sort of run into that when the standard library, maybe you have a network connection problem, and your standard library is returning you a string. Now you're forced to parse it out to figure out which kind of network connection it is. These are things that you generally don't expect to be doing. So that's an area where it can be a mess. And as a guideline going forward, if you're building a library, I'd recommend you to have constants and things that are sort of more strongly typed errors so that your user can check those in sort of a very straightforward way and not have to deal with this string parsing mess. Now, I couldn't talk about Go without mentioning garbage collection. If you're not familiar, Go is a garbage collected language, and that brings with it a whole set of issues. So the standard advice you always get is, don't make any garbage. Well, that's obviously simple, but maybe not quite so simple when you get down to it. So obviously the first thing you're going to think about is you need to be mindful of all of your allocations. Now that's again something, so the beauty of garbage collection is you can write it and not think about it, but when you're going to ultimately take your code to production, you do have to think about it. In particular, you want to be mindful of operations that are copying data. And I say that because a lot of times operations are copying data that you don't even realize. One of the most common ways here, I called out a couple of them. Anytime you're converting strings to slice of bytes, that's another opportunity where that's, except for a few corner cases, that's almost always a copy of your data. A lot of the standard library functions that operate on a slice of bytes also create a copy. And sometimes you're not expecting that. So an example would be there's a method to replace a byte inside of a slice of bytes. And that's going to return a copy, again, somewhat unexpectedly. Now, once you start trimming this down and you start avoiding making copies, you have a different set of problems, which is now you need really clear ownership of who's ultimately responsible for that byte slice. We've been bitten by that quite a few times where we were lazy about it, so we had copies. We then went back and got rid of all the copies, and then we found we were mutating that byte slice in various places and had a mess to clean up. Now, part of being mindful of your allocations is reusing objects that you've already allocated again. Frequently, the standard in Go APIs is to have a reset method. That's going to allow you to take an existing object that's already been allocated, reset it to some state where you can reuse it. And hand in hand with that, there's a feature called sync pool, which is sort of a language feature built in to the API here where we can reuse, essentially pool objects. Now, this is not a general purpose like cache, if you will. What you want to think about it is it generally works best when you have a very clear start and end life cycle for an object. So every time you need to start it, you're going to get something from the pool. And then when you're done with it, you're going to reset it so it can be reused and toss it back onto the pool. That was introduced in, I think, Go 1.3. And so if you were using, you end up having a lot of handcrafted solutions that do the same thing. And then we've rewritten all those to use sync pool. And that has a lot of advantages. So you definitely want to evaluate sync pool for that purpose. Now, sometimes you have some performance issues, but you're not sure if you've got a garbage collection problem. So what are some things to look for? Well, when you review the CPU profiles, if you see something like runtime malloc GC, that's a good indication, right? And that may not be a high number. Even a small number is still, that's like a percentage that, in an ideal world, that's 0, right? So that's time you could just take back from your application. Another useful thing, I always preach about this in every talk I give about Go. There's a library called Xbar. So it's part of the Go standard library. And what that allows you to do is export variables through some other interface. Typically, you expose them over HTTP. And by default, without doing anything else, it's going to expose a long list of maybe 50 properties, 2 of which are really useful. One is how much memory is currently allocated. And the second one is a counter of how much the runtime has spent doing garbage collection. So that's a counter that just keeps going up and up and up. And if you collect that data and you plot it, you may see a little pattern like this, kind of a sawtooth pattern, where the memory allocated is going up, the garbage collector kicks in, and we see a corresponding line right there. And then your memory is going to drop back down after the memory's been garbage collected. Again, I'm not showing any particular pattern here. That's just an example of how you can use that tool to collect the data and analyze your application. Now, if you have really severe garbage collection issues, you may want to look to another feature. What we're seeing here is a visualization. It's a tool written by Dave Cheney called GCViz. This leverages the fact that if you launch your program at runtime with the Go debug environment variable, you can set a value which will basically cause it to print a line for every important operation that the garbage collector is doing. This visualization then collects those and draws a chart. Now, I would venture a guess that in most cases, you're not going to need this tool. But if you do get into some really nasty garbage collection issues, you certainly want to be aware that tool's out there. Now, I mentioned looking at the heap profiles and the CPU profiles. Sometimes you're going to look at it, and you're going to see that a particular function is causing garbage, and you're not sure why, right? You look at it, and you think, well, this variable looks like it should be on the stack. It should be freed as soon as the function exits. I don't understand. There's another option you can use with the compiler, this -gc flags equals -m. What this is going to do is it's going to cause the compiler to print out the escape analysis that the compiler is performing. So for every variable, it's looking to see, does this variable escape, in which case I need to allocate it off of the heap, or does it not escape, in which case I can just toss it on the stack. So again, I have some sample output here. Again, it's fairly verbose. If you run this on a large project, it's going to run through all the dependencies. You'll have pages and pages of output, so you do have to kind of grep through it. But generally, you have a particular function or variable you're looking for, and you can sort of search through it and find what you're looking for that way. But again, that's a very useful tool, because sometimes you'll find that you've confused the compiler in some way, right? There may be cases where it really can be allocated off the stack, but the way you've written the construct, it's confused the compiler, and this lets you identify those and fix them. Now, there are a few more solutions for advanced users. And I say advanced users because these are things where you're kind of going outside of what the runtime's offering. And these are things where, as the runtime improves over time, you're maybe not going to take advantage of that. And you're also sort of entering in a world where if you're not smart about what you're doing, you could actually do something worse than what the runtime's offering you. The first is slab allocation. So this is sort of an approach very much like what memcached does, where we pre-allocate a bunch of memory, and all of our allocations are operating out of that. We've experimented with that internally, so we do have a project called Go Slab. I would not recommend you use it in production at this time. It's something we've used mainly for experimental purposes. But we're not using it on any production apps either. But it's there if you want to look at it. And another is a technique called off-heap allocation, which sounds similar, and it's kind of just a minor variation here. What people have observed is a lot of times you have, well, in terms of the way the garbage collector works, if you have a large number of pointers, the garbage collector has to look at each of those and see if that's data that can be garbage collected. But what happens is you have some constructs that maybe have a large number of pointers for things that you, as the developer, know they're never going to get garbage collected. But the runtime doesn't know that. So a good example would be, let's say you have a map of a lot of like sampled or like reference data that your application is going to use over and over again. So you read it in, you put it all in a big map. Maybe you have gigabytes of data in this map. Well, each of those pointers, there's a pointer inside of the map for each of those entries. And every time the garbage collector gets run, it's going to have to walk through all those pointers, even though you know that's stuff that's never going to get collected. And because of that, people have created some data structures that offer the same map API, but then allocate, they're working with memory off the heap so that the garbage collector is not going to have to process through that. I didn't list any out. There's several out there. If you look into them, you'll find those. So we've already covered a lot about memory. Are there any other memory surprises? Well, oh yeah, there are. So let's take a look at one fun one I worked on. Sync Gateway, as I mentioned, was one of the first apps to go towards production with Go. And we started doing performance testing, where we were trying to scale up the number of concurrent users. If you're not familiar with Sync Gateway, it's what's basically talking to the mobile devices on the server side. So we're ramping up the number of concurrent users. And what we observed was, with about 20,000 users, we had 20 gigabytes of memory that were being taken up. And that didn't seem to fit. It didn't make sense it would need that much. There's a lot of like really small requests and responses being sent back and forth. So what do? We took a look at the heap profile. And I've highlighted the first line there. This is obviously a smaller run because that's only about 4 gigabytes of RAM. But it stands out right away that 97% of the memory has been allocated by this one function, compress/flate. So that was sort of an obvious thing to look at. So what do we find? Well, as I mentioned, we're talking to mobile devices. So it's sort of a no-brainer that we want to gzip the responses because we're trying to send as few bytes as possible down to the client. So the simple, naive implementation we had was inside of the method that was generating the response, we created a new writer using that new writer method, used it to create the output, and then when we're done, that was it. We just let it get garbage collected. Well, it turns out the implementation of Flate Writer allocates a 1.4 megabyte buffer to do all its work, even though the responses we were dealing with may be less than 10K. Again, this is an example where we were able to observe the fact that there is a reset method on that writer, so we didn't have to create a new one each time. We could reuse the existing one and use sync pool to sort of create and get rid of those as well. One final topic on memory. Slices are great. If you're not familiar with Go, slices are really just like subsections of arrays. And in Go, that's really the primary way you interact with bytes. Slices are great, but there's some like hidden memory issues that you need to be aware of. So let's say you were to read a 1 megabyte slice of bytes. off of the network and bring it into memory. And you sort of parse through it, find something. Maybe there's a key that's of interest to you. And maybe you return another byte slice that's a subsection of that, which is only 16 bytes. Now, you may not reference that other buffer anymore. You're just keeping a reference to that one 16-byte slice within it. That's going to hold the entire 1 megabyte until you release that reference. So you really need to be aware that if you have these long-lived slices, and if they're very small relative to the buffer they came out of, it may in fact be cheaper to copy the bytes in those cases to ultimately free up the larger slice. So it's a lot about memory, but we're done with memory. So everybody take a deep breath. Briefly, I'm going to talk about Go routines and channels. Go routines, right? You're sort of taught right in the beginning, these are lightweight, you can create them, don't worry about it. And they are, right? But they're lightweight, but they're not free. And what we've ultimately found as we've started using these things is developers seem to forget that channels, they're not just a communication mechanism. Because you're communicating between concurrent processes, it's a synchronization mechanism, right? So, and as we know, synchronization comes with a cost, right? There are locks underneath the hood. It's not magic. Locks are what make this possible. And so if you find you're using channels to connect up a bunch of sequential things that aren't concurrent at all, you're really not doing that very intelligently. So you really need to be sort of smart about how you're using Go routines and channels. Like I said, don't get me wrong, they're great, and you just have to use them correctly. Another very big topic in the Go world is repeatable builds. Everybody loves to complain about this. Everyone's using Go get, so I see some looks, so maybe people aren't familiar with this. So in the standard Go tooling, you would use Go get to retrieve a package and install it. And the way you reference packages is with a URL structure. And what happens is, that's not pinned to any particular branch or version. So you may today, let's say I have a dependency on a library, so I do Go get that library, I get the version, I develop against it. But Matt comes along later, and he's developing the same thing, and he does Go get. He gets a different version. Maybe the API's even changed. He says, well, it doesn't build for me. It still builds for me. Again, that's a short example of it in a nutshell. So what do we do at Couchbase? Well, all of our new and prototype projects still use that method, even as crazy as that sounds. The good thing about it is it's very low friction, right? Everybody can just sort of do what they want. Things do break. That's the reality of it. But for a lot of these projects, when you're in that phase of development, that's OK. When they break, you send an email, they fix them, no big deal. But no one's going to pretend that's going to work for production builds. So Sync Gateway was obviously the first project that ultimately had to come up with a better solution for this. Their team was growing. They weren't in production yet, but their team was growing. They all needed to be on the same page. So they went ahead and created a custom solution. The way their solution works, they vendor the dependencies, which basically means create a copy of the dependencies. They're using Git submodules for most of them. They then have wrapper tools. So there's a set, to correspond with all the Go commands, you have Go sh, build sh, run sh. Those are corresponding to all the Go subcommands. And I mean, the best thing I can say about this approach is it does work, and they're happy with the solution. I don't know that I would be happy with the solution, but they like it, right? And so, good, it works. But I can tell you some of the pain points I've run into with this approach. When new tools come along, like Go Oracle or something like that, which is actually another cool tool you should look at I didn't mention. But if you're using Go Oracle, it's another tool that relies on the Go path being set up correctly. And so you have to keep going back, and maybe I would have needed to create another script for that. It becomes a lot of work. The same thing with IDEs, where they maybe make assumptions where you just have maybe one big Go path, and you've got everything accessible through that. You have to find a way to sort of make it work with these other projects. But we then advance beyond that. We have other projects which are now integrating with Couchbase Server. And Couchbase Server already has a very well-established process for repeatable builds. It's based on the repo tool. And it's actually like, it seemed like a point of friction, like how are we going to solve this using repo? But it actually turned out that actually became a great part of the solution. So what we've done is we have an additional issue, which is we don't want to rely on external dependencies just disappearing. Right? So the first thing we do is we clone a copy of all the repos we're dependent on into a separate organization called Couchbase deps. That allows us to essentially pin those to a particular version and not worry that the maintainer of those projects just deletes them. Second, the repo tool is what actually goes out and retrieves all these things and lays it out on the file system. So what we're able to do is point it to that Couchbase deps so that when we reference a particular package, it's looking for it inside of the Couchbase deps organization. But then when it goes to lay it out on the file system, you notice that path is just the canonical path. So that's the original path that the package came from. So the advantage of that is we don't have to rewrite any of our source code to point to alternate packages. It's very clear which package it ultimately was coming from. Again, I'm not going to pretend this is a perfect solution, but it actually is pretty clean. There's some more work going on in this area with Dave Cheney with a new project called GB. It's different. It's a very different implementation, but when you look at how it's actually working, it's actually very similar in terms of the way it's separating out from go get and laying out the packages in a particular structure. So this may not be the final solution forever, but we're pretty pleased with the way it's working today. It solved the immediate problems we had, and it's allowed us to get past that. And as I said, this has the big advantage that if you set your Go path correctly, all the existing tools are working out of the box. You don't need to have a separate set of wrapper scripts to manage that. Another major pain point, CGO. At Couchbase, we're using a lot of different libraries that are written in C, and we need to interact those from inside of Go. Largely, that's a success story, I would say, but there's a couple gotchas. On Windows, it actually depends on GCC. Now, you might think that doesn't sound like that big a deal, but we recently went to great pains to remove GCC from our Windows builds. We wanted everything to be using the standard MSVC toolchain. And this was now another wrench thrown in that process. We briefly considered using another approach where we would build the DLLs manually and then dynamically load them, and we'd have some wrapper that would load and call into the right entry points. And that works, but as you can imagine, there's a maintenance cost now. Every time you change your API, you got to update the wrapper. It became a painful approach, and we ultimately decided it wasn't any better than the alternative, which is we're back to installing GCC on the Windows box, the build boxes. We're not happy with it, but that's where we are. So that's sort of a longer-term fix is needed. Another issue is getting reliable core dumps. So as you can imagine, you got a Go library calling a C library, and let's say there's a segmentation fault inside that function. You're going to want a stack trace giving you, you want to see the Go routines, you want to see the stack inside of Go, and you want to see it all the way down to where it actually crashed inside of C. And if you had a debugger attached when it happened, you'll actually be able to get that. But if you don't have a debugger attached, which is, let's say, what's actually going to happen on your customer's machine when they're running your code, you're going to want to have a core file generated so that you can perform a post-mortem analysis to get the same thing. And we have not solved this problem yet. We get some of the stack. It's often leading not to the source of the problem, but to a signal handler inside the Go runtime. And so these are things that, this is a major deal, right? I mean, if we're going to support code running on customers' machines, we need this to work for us, or we've got a major problem. And like I said, the only workaround we've come up with is when we use GCC Go, which again, not to be confused with CGO. That's an alternate compiler. That works, that solves this problem, but it introduces a whole host of other problems. So we're not happy with that either. Now, I just want to wrap up with a few thoughts. I didn't write it down, but I should say developers are really happy with Go. If I really were just be honest with everyone, we're very happy with the solution. But I think, to me, the big thing is Go at Couchbase is really at a crossroads right now. Why do I say that? Well, we have real problems, and they need real solutions. Option one, we're going to solve the problems and contribute it back to the community. That's obviously the best case scenario. And we have a history of that. At Couchbase, we've had issues with Erlang, and we've fixed them, and we've contributed them upstream, and that's a success story. But there's always a cost associated with that, right? So that doesn't always happen. So sometimes you solve the problems, and you don't contribute them back. That's less than ideal, but in the real world, that happens, right? I mean, maybe you decide it's going to cost too much. There's people involved. There's egos involved. Sometimes there's the way you solved it's not acceptable by upstream. So there's all kinds of reasons why it may not happen. And so that's another possible outcome. And finally, to be realistic with you, there's another scenario in which we don't solve these fully. We ship something that we can't really support as well as we'd like. And the downside of that is, I can tell you what that would mean is long-term, we'd slowly start to move away from Go and say, well, we couldn't solve the problems, and so we had to start backing out of that. I don't think that's likely. I think the reality is it's going to be some mix of all three of these. But that's still in front of us. That's for us to solve. So with that, I'm going to hand things over to Matt, who's going to talk to you about the Go SDK.
Great. Thank you, Marty. I appreciate it. Obviously, we have a lot of experience with Go at Couchbase. And so every once in a while, somebody comes up and asks, hey, where's your Go SDK. I want to write Go code to actually use Couchbase. And there's kind of a funny little history here, because this had come up before with another programming language, Erlang, right? So the cluster manager in Couchbase is written in Erlang, and it works well. And if you were to crack open the thing that we call NS Server, it might be even in a different project, but if you were to crack it open, you will see all of the things necessary to talk to Couchbase in there. However, the way you write those things internally, when you are the system, the way you write things is very different than the way you would write things if you were outside the system, right? We want to make it easy for the developer. So, as kind of an introduction to that, what does it actually mean to be a Couchbase SDK? So, if I were to define it, I'd say at the lowest level, there's really this sort of cluster layer. There's this layer that's who's responsible for holding on to information about the cluster, such as the topology. It has little bits of detail that you may have, really just some state that you may need to reference as you're working with that SDK. So the API, things that pop out of that API are things like open a bucket, get information on the cluster, disconnect from the cluster, clean up resources. At the next level is really the bucket, right? You guys all at this stage probably know what a bucket is. Buckets are a little overloaded in that they're a unit of resource management as well as a unit of multi-tenancy and a namespace. But it's in the SDK, its function is really to manage connections to that bucket, because that's how the interface is defined at the cluster. And it provides this core layer where we'll optimize I/O. We'll do things like we'll pipeline operations. We'll manage. We'll do as much as we can, as well as inspecting things. So things like insert a design document if you're working with a given bucket, flush, list design documents, bucket management operations. But we haven't really gotten to anything where we work with data yet. That's the next layer. So there's this layer that's sort of, or this section of what it means to be an SDK that you might call the crud layer, right? And so this gives the application developer, you guys, the ability to really write concurrent applications in a very easy, reasonable sort of way, as well as have a good way to understand things and do error handling. So that API are things like the get, insert, upsert, remove that you're familiar with from all of the other SDKs. We usually try to have a common approach with all those SDKs. Then there's a layer that's really all about view querying. So one of the services that Couchbase exposes is something called views. Views are an incremental MapReduce internal to the system. You kind of define them on the server side, and then you can call out to them from the client. And those are effectively range queries across those views. So in this case, really we want to have reasonable error handling, and there are lots of different options on top of views. So for an SDK, a good example would be that we'll frequently have these fluent type interfaces. So if I'm referencing a bucket, I want to create a new view query, and I've taken out the parameters that normally go inside the parentheses here. I'm going to create a new view query, and then I maybe want to set some options, like I want to limit back from it whether or not I want it to be stale. And those may have some constants that fall in there to help me fill that out. And then similarly, Nickel kind of follows sort of the same pattern. So we want that to allow for querying execution. Other directives like defining indexes and checking on index state. So as indexes are defined on the system, sometimes need to check. If you're creating an index over billions of items, it may take a little while. So you want to check on where is it in the process of being built. And so the API for that also follows that sort of fluent API approach, where you'll define a new Nickel query. And then this is a really simple example where we're just dropping a string in and we're saying what the consistency requirements we have for that statement are, in this case, request plus. So pretty straightforward. So after you understand all that, then what does it actually mean for us to build an SDK for Go? Well, what we want to do, and the credit actually goes to Brett Lawson, who's here in the audience. He wrote the SDK, and he's part of the SDK engineering team. We wanted it to be, if you were to kind of look at Go philosophy, and you guys are probably, Marty certainly is more of an expert than I am, and I know others in the audience are, but it's really that you want easy to read and write under code built for concurrency, obviously Go and Go routines. with type safety. And also, all of the concurrency primitives, there's sort of a lower layer, if you will, there. There are mutexes. You can work with Go at a much lower layer if you need to. And so we wanted to kind of follow that same philosophy. So really what we have is we have a Go CB layer. And Go CB is really, if you will, the interface that we expect most application developers to use. So that's the place that is iterating towards interface stability. The Go SDK is not yet in a 1.0. It's in a developer preview right now, although it is pretty high quality. And we actually have it passing a set of tests internally, but we have a lot of work to go on unit tests to get to Marty's ideal of 100% code coverage. And then there's Go CB Core. And Go CB Core, that's going to be a volatile interface for some time. So it's there, you can use it, but don't be surprised if something changes regularly. So if you were to look at the Go CB layer, what does that look like? Well, it gives you kind of a synchronous, there is a synchronous-like interface and, as well as an asynchronous one. So frequently when you're, I'll talk a little bit about JSON in a moment, but if I'm going to retrieve a user, go retrieve a user profile, it might look something like this. I'm defining a new variable. In Go, you have a empty interface, blank interface. Everything implements the blank interface, so that's sort of the functional equivalent kind of object, say in Java or something like that. And so when you define that, then you can go retrieve information. You'll just have the normal, I want to get a set of users. But there's also an asynchronous interface. So once you start going async, now you have things like a signal via channels. So here I have a Go function, a set of Go functions, and if I want to go retrieve all those users, I can go do that in parallel asynchronously. And the cool thing is that the Go SDK will go ahead and push those out in parallel. And if they're on different nodes, you've got network traffic going to all of them in parallel and coming back. There's also the Go CB Core side. So on Go CB Core, now this is the layer at which you're dealing with everything. So I didn't mention it at the time, but here we're actually doing a lot of things with transcoding, understanding the data types, et cetera. On the other side, we're really we're exposing all the details to you. So when a request response go over the wire, there are things like metadata. What kind of flags are you using? What is the expiration time, et cetera? And obviously, some of those need to get exposed up here at the SDK layer, but wherever possible, we try to simplify that for you, right? If the SDK and the cluster know that it's a JSON document, then we'll go through the JSON marshalling for you. So speaking of that, CBGo does use Go's support for JSON internally. I didn't necessarily mention this, but there's Go-Couchbase. Then later there was Go Couchbase with no dash. And then later we renamed it to CBGo. And CBGo is the one that we're iterating on as a public, an SDK for developers to use. And then internally, we're hoping eventually that Go CB Core is going to be the thing that other projects can pick up on, and we'll add features there as needed for other Couchbase projects internally. What can you do with that? So for example, if you were to define a struct, type beer full struct, the reason it's full is because it has all the attributes, and you can unmarshal that straight into that struct off of a get. So if I were to define that beer, and then I were to go say I want to get it, the underscores here basically tell the Go compiler I'm not going to use those variables. So it'll return multiple. Go has multi-returns. I guess that's the right phrase to use. So when you call a function, you may get multiple responses. You'll get multiple variables in response. And if there's no error, you write it out. Otherwise, hey, we've passed a reference to the beer. It'll automatically unmarshal it into that struct we've defined, which is really, really useful. So if you're working with JSON data, really quick and easy to work with. Now, like I said, high-level concurrency in Go is great from a programming perspective, right? But it turns out that it's not always the most performant way to use the language. And just like I remember our colleague Steve, we were looking at another project, and it was actually another database project. And Steve said, "Oh, this looks like they wrote Java minus minus." So basically, if you're writing Java code and trying to stay out of the way of the garbage collector, just don't do anything that generates any garbage, right? Lots of things like, oh, well, I'm creating buffers, and I'm just putting my data in buffers, and so forth. And so Go is similar. Go is a little better that you don't end up, you don't have to do that because you have all those primitives. So if you're right, if you want to get the highest performance, really that's what we've done, or what Brett has done with Go CB Core, where Go CB Core is mostly lockless. It really has, internal to Go CB Core, you have a concept of a pipeline, and all operations will go through that pipeline. And then the entire, in the core, there are really only 2 locks inside that. One is a coarse grain lock, which is a read-write mutex, only used in the case that something goes wrong and we got to go clean things up. So now we got to go shut other connections down. There's also a fine-grained mutex on the operation list. So this is the list of operations that we're working with. So when things are being added and removed to the pipeline, we have very fine-grained locks. So we try to lock as little as possible. And then what that gives us is the ability to expose all of that to you, and you can just use it with Go routines, and things work as expected, but we get the highest performance that we can out of the system. I should also mention, Brett had talked with some of the folks at Google based on one of his blogs, I think it was, and the Google product manager called and said, hey, love to see what you're doing here, and they had a conversation about the kinds of things that we can do in the future. I should also mention, though, that the Go CB Core, I mean, there are things that we're using in there, in particular the map. It may have other locks internally, so you will see that as well, or some of the core language may have some of those. So I want to do a little bit of a demonstration here, if that's okay, because I love doing live demos. So 2 things I want to show you. One is oh look, I'm supposed to be in a meeting right now, presentation. The first one is, if you've been working with Couchbase for a while, we ship a sample application or sample database, the beer sample database. I know it's my favorite of the 3 sample databases, and so it's just kind of a fun data set to work with. And so as we were developing the Go SDK, it was sort of the place to try building an SDK. Sometimes when you're building those things, there's a little bit of art, if you will, in addition to the science. You kind of want to feel it out and say, okay, does this feel like something I like to use? And so that's in effect what Brett had done here. So really all this does is it's using the beer sample database. Who doesn't know what the beer sample database is? Do I need to describe it? One person way back in the back. Oh, 2, okay. You don't know what it is? Oh, you know. So it's really just a sample database that has breweries and beers, so we can show relationships. It has flexible structure, because not all beers and breweries have all the same items or all the same attributes, so we want to be able to handle for those things. I've got that data bucket here. And then what you can do is do things like search beers. Somebody name a beer. Oh, come on. Somebody knows. Red Pelican? How do you spell that? Shime? Okay, I know that one. There we are, Shime Dora. And so you'll notice as I'm typing through, it's automatically picking that up. So the front end is just some very simple, if I recall correctly, it's just Twitter Bootstrap plus a little bit of jQuery. We try to keep that as simple as possible so you can introspect the app pretty easily. So if I click on one of them, the beer will come up. So let me show you just briefly what that looks like in code. We're running a little bit out of time. So pop in here, presentation mode. So when I go to do a search for a beer, really you're getting this the beer search handler. This is based on actually some things that are part of Core Go. I'm going to build a query to go find things from the beginning to the end, starting based on what I type in. And once that query comes back, I'm going to go ahead and retrieve the beer itself. So the beer is defined earlier as a struct. As you notice here, here it's actually using beer, not beer full. So this is actually getting the minimal attributes in this particular case to retrieve that. So then in each one of these, let me actually, I think the best way to do this, view, tool windows. We're running out of time. Since we're running out of time, I'll just, but the best way to do this, view, exit presentation mode. So what you see is, and the code is up there, tool window, project. What you see is we have templates for each one of these inside the sample application. I did want to do one other quick thing, and that's because this one's kind of fun because those who know me, I always like to show off performance a little bit. So default bucket, local machine. Let's see what we can do. I played a little bit around with this last night. So on the Java client, we normally get about 15,000 ops a second, if I recall correctly, if you write the dumb benchmark that we talked about in the Ship It app earlier. So we're going to do something similar here. So this is just a really simple one. If I recall correctly, oops, let me get to the right one. Go fight. So really what we have is we are actually going to run 8 of these at the same time, where we're going to just go do gets against the cluster. So just a small one. So let me go ahead and hit run on that. And what we should see is a little bit of load here. And sure enough, OK, we're going up. So about 88,000 operations per second is usually what I've been seeing. And there are a couple of interesting things in this case. I think Go max proc is actually at 1. Interestingly enough, it was set for profiling, and then I played around with it a little bit, and I found that I was getting the best throughput at 8 or so. So on a local machine, and it's actually not too bad. The CPU time is actually getting counted by IntelliJ, so it's not really using all that much CPU, as you can see here. The cluster actually isn't even doing all that much. So this beam.smp, that's really all about rendering the graph. And doing some other work in the background. So for the most part, system's handling it just fine. I could probably find a way to push it further. So with that, I want to ask Marty to come back up, and we would love to take any questions. Yes?
I assume you would compare Google Go and
GCC Go, or? Oh, Rust?
I don't know.
Erlang?
Erlang, I'm sorry.
Oh.
Erlang, because you use both languages.
Yes.
And the way I see it, they kind of competitor in a way.
I actually, so Marty may have a different answer, but I actually don't see the two as competitive in that Erlang to me is more, I'm going to be an entire virtual layer and give you new constructs in the world of Erlang. So Erlang, you have things like OTP, where you can do RPC among lots of different systems, et cetera. And so you don't necessarily, it's trying to hide a lot of the system from you. Go, on the other hand, is kind of lives a lot closer to the system. So you'll see things like, it's fairly straightforward, I would say, to go take some native code, as we have with ForestDB, pull that into a Go program, and that's intended there. In Erlang, you can do that with NIFs, but Erlang really is, it's trying to be your scheduler. It's trying to do all of that for you. So to me, they're very different. For concurrent programming, yes, in that Go has, Erlang has what it calls processes, and processes in Erlang are more like fibers or lightweight threads. They don't have operating system level threads. And same thing, same sort of thing in Go, exactly. Yeah, so that aspect, the two are done. I'll take one last question, then we're going to wrap up. Yep.
You're saying that Go right now is going in this crossroad and Couchbase. Are you planning to support the SDK of Go at a certain time, or are you planning to drop that?
Yeah, so in effect, the question is, are we going to have full GA support for the Couchbase Go SDK? And the answer is yes, absolutely. We're definitely working towards that. In fact, I forgot I did have one other slide. So current release is 0.2.0. Our goal here is to release early and often and get feedback. So roadmap, we're going to continue iterating on those, do nickel support, get durability requirements done. Durability requirements are things like I want to make sure it's in 2 places in the cluster before I can consider myself done. And like Marty said, get good test coverage.
Yeah, one thing I'll just add to that. When I said Go is at a crossroads, I see that more as Go as a implementation of software inside of Couchbase. The Go SDK, I think, yeah, that's going to be fully supported, and we have we're not wavering on that part of it, right? It's more about, will we continue to use Go to build things inside of Couchbase? And that's to be decided. We'll see.
Great, thank you very much.
Thank you.